Assalamualaikum warahmatullahi wabarakatuh. Today, our group will be present about direct shear stress. This test is carried out on either undisturbed samples or remodeled samples. To facilitate the remodeling purpose, a soil sample may be compacted at optimum moisture content in a compaction mode. Then, specimen for the direct shear stress test could be obtained using the correct cutter provided. Alternatively, sand sample can be placed in a dry state at a required density in the assembly shear box. A normal load is applied to the specimen and the specimen is sheared across the predetermined horizontal plane between the two halves of the shear box. Measurement of shear load, shear displacement and normal displacement are recorded. The test is repeated for two or more identical specimens under different normal loads. From the result, the shear strength parameters can be determined. The objective for this test is to determine the parameter of shear strength of soil, cohesion and angle of friction. After that, to determine the shearing strength of the soil using the direct shear apparatus.
Theory. The strength of a soil depends on its resistance to shearing stresses. It is made up basic of components. First, frictional, due to friction between individual particles. Second, cohesive, due to adhesion between the soil particles. The two components are combined in Coulomb's shear strength equation. Tau F is equal to C plus sigma F multiplied with tangent theta, where tau F is shearing resistance of soil at failure, C is apparent cohesion of soil, sigma F is total normal stress on failure plane, theta is angle of shearing resistance of soil, which is angle of internal friction. This equation can also be written in terms of effective stresses. Tau F is equal to C prime plus sigma prime multiplied with tangent theta, where C prime apparent cohesion of soil in terms of effective stresses. Sigma prime F is effective normal stress on failure plane. Theta prime is angle of shearing resistance of soil in terms of effective stresses. Sigma prime F is equal to sigma F minus sigma UF, where UF is for water pressure on failure plane. Apparatus. These are the apparatus for the experiment. First, shear box carriage. Second, loading pad, perforated plate, porous plate and retaining. Third, weighing scale and scope. And lastly, deformation dial gauges.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nuratika binti Nazwan and my registration number is 01DK80F2044. So I would like to present about the data and analysis. So in the shear box test, the specimen is not failing along its weakest plane but along a predetermined or induced failure plane. As example, horizontal plane separating the two halves of the shear box. This is the main drawback of this test. Moreover, during loading, the state of stress cannot be evaluated. It can be evaluated only at failure condition. Next, direct shear test is simple and faster to operate as thinner specimens are used in shear box. They facilitate drainage of pore water from a saturated sample in less time. This test is also useful to study friction between two materials and one material in lower half of box and another material in the upper half of box. However, the angle of shearing resistance of sand depends on state of compaction, coarseness of grains, particle shape and roughness of grain surface and grading. It varies uniformly grained sands with round grains in very loose state to well-graded sand with angular grains in dense state. Other than that, the volume change in sandy soil is a complex phenomenon depending on gradation, particle shape, state and type of packing orientation of principal planes, principal stress ratio, stress history, magnitude of minus principal stress, type of apparatus, test procedure, method of preparing specimen and others. In general, loose sands expand and dense sands contract and volume on shearing. There is a void ratio at which either expansion contraction in volumes takes place. This void ratio is called critical void ratio. Expansion or contraction can be inferred from the movement of vertical dive gauge during shearing. Last but not least, the friction between sand particles is due to sliding and rolling friction and interlocking action. The ultimate values of shear parameter for both loose sand and dense sand approximately attain the same value. So, if angle of friction value is calculated at ultimate stage, slight disturbance in density during sampling and preparation of test specimens will not have much effect.
Hello madam, my name is Dinesh son of Damotaran, my matric number 01 DKA20F2055. So I'm going to present about the discussion and conclusion in the direct shear test. So let's begin with the discussion first. The direct shear test is suited to the relativity rapid determination of the parameter of the shear strength of soil at these three samples, which are 1.75 kg, 2.5 kg and 3.25 kg. There are no error data obtained. The value obtained from the digital gauge show increased direct. This is because the dial gauge reading has increased the time by the time. The cohesion of soil and the angle of the friction of the soil are determined. The angle of the friction is the angle of the linear line produced line slope. From the graph, the cohesion of the soil is 0.0 kN square as the sample of the soil used is sand. As we know that sand is type of coarse grained soil and it is assumed cohesion less. From the graph, the angle of the friction is 35 degree. The direct shear test has advantage and disadvantage. It is simple and fast, especially for the sand. The failure that across is long is a single surface which approximately observed slips or shear type failure in nature soil. Let's move on to the conclusion. Direct shear test is useful when cohesion-less soil are to be tested. In this test, the failure plan is forced to occur at the predetermined location where both normal and shear stress are attained. The sample is placed in a closed shear box fixed at the base with the top free to translate under a horizontal force. The two portions of the box are placed by using spacing screw to reduce the friction. The space should be at least as large as the largest sand particle. The box is then placed in the direct shear apparatus and increasing the horizontal load is applied with the consistent corresponding vertical load and the horizontal deformation should be recorded by using the dial gauge. For each test, shear stress strain diagram is drawn in order to find out the ultimate stress. Then the shear failure envelope is drawn by relating each ultimate shear stress to the normal stress corresponding to it in at least 3 tests. The direct shear test can be used to measure the effective stress parameter of any type of soil as long as the pore pressure included by the normal force and the shear force can be dissipated with the time. For the experiment, we use the clean sand as a sample, so there's no problem as the pore pressure dissipates readily. However, in this case of highly plastic clays, it is merely necessary to have a suitable strain rate so that the pore pressure can dissipate with time.